Same problem. Now, use the alligation method. Which method do you prefer? Take some time and work on it yourself. If you get stuck, press play. Alligation method is used when we have 3 concentrations. For this problem, there are only 2 concentrations, but we can make the 3rd concentration 0 because there is no drug in D5W. Note, in this case, we are not concerned with dextrose 5% at all. We are only concerned about the concentration of drug, not the concentration of dextrose. Remember that all concentrations must be the same units. The concentrations given from the question are 10 mg per ml retrovir. We got that from reducing. And the other concentration is the final concentration that we are trying to get, 2 mg per ml of retrovir. And we make the last concentration 0 mg per ml because there is no drug in D5W. Now, how do we set it up? I like to make a tic-tac-toe board and add one more line to set it up. Here's what it would look like. We put concentration starting here in the outside boxes, and the desired final concentration will go in the middle. We subtract diagonally to get the amount of parts. And then we have milliliters here. In this case, we use milliliters because for this question, it is a liquid. You might also notice that they ask for milliliters of dextrose in the question. How many milliliters of D5W do we need to add? How do we fill it in? We know that we reduced the concentrated solution. We've reduced it down to 10 milligrams per ml. And the diluent is D5W. There is no drug in there, so we call it 0 milligrams per ml. Our desired or final concentration, we will mix these two to make this in the middle. Notice that you can always have the highest number on the top, the lowest number on the bottom, and it will all fit into place the way we want it to. Subtract going diagonally. 2 minus 0 is 2 parts. 10 minus 2 is 8 parts. Since the question asked for how much D5W, which is the diluent, I'm going to put my X milliliters in this bottom right corner. Notice that we do not know how many milliliters there are here. How do we do that? How do I find the starting volume of that available solution? That's right, find the required dose, then divide by the concentration, or use dimensional analysis to cross out units. That's what I like to do. Here's the desired dose, 1.5 milligram per kilogram times 2.5 kilograms, which is the weight of the patient. We get the milligrams required per dose. We can use the required dose to find the volume of the available solution that was in question. It was the one that we reduced from 200 milligram per 20 ml to 10 milligrams per ml. Now we take that dose we put it here, and the concentration, we put it here, we cross out milligrams, and we get our answer. This is the volume that represents the required dose. Now we are able to enter that into our tic-tac-toe board here, 10 milligram per ml all the way across, and we get our 0.375 milliliters. Now this is the fun part. All I have to do is box in the area. I made a proportion. I made on the left-hand side 2/8 equals 0.375 over x. So then I cross multiply and divide. Cross multiplying and dividing will get me 8 times 0.375 divided by 2 equals 1.5 mLs. This is the answer.